All right, as we continue on here in Chapter 5, we're going to look at Section 5.4 today, continuing with those similar ideas of yesterday with concurrency of where these segments within a triangle are going to intersect. Yesterday in 5.3, we looked at the perpendicular bisectors and the point of, we also had the angle bisectors. So today we're going to look at another one, which would be the medians. So the median of a triangle, if we can go ahead and define that to start, is a segment whose endpoints are a vertex. So these lines are coming out of each angle. They're not going to be angle bisectors this time, though. Instead, they're going to span to the opposite side of the triangle and connect to the midpoint. So vertex, midpoint. And we can see that that's a midpoint because it split that opposite side into two congruent segments. So theorem 5.8, concurrency of medians theorem. What happens here, not only does it create two congruent segments by splitting one side of the triangle in half, but we also have a relationship. When these all meet at this point of concurrency, we now have a relationship between this part of that median and the whole median. So basically looking at DC all the way to DJ. Now each median has that situation where we go from a vertex to that point of concurrency, and then we keep going past that point of concurrency. So vertex to the point of concurrency, and then point of concurrency to the midpoint. So what we're saying is that red part, DC, is 2/3 of that blue part. So DC is 2/3 of the entire thing. So you might be thinking that makes CJ 1/3. Right? Put some green in there. This is 2/3 of the way. That means this is 1/3 of the way. This is 3/3 the whole way. And that happens with each of the medians. We call that point of concurrency the centroid, which is the coolest of them all. So the point of concurrency of the medians. So in the diagram at the right, XA is 8. What is XB? So you might be thinking of that logically, but I'm just going to set up the theorem real quick. We know that XA equals 2/3 of XB. So that means 8 equals 2/3 of XB. So think about how you want to solve that. If this is our variable, XB, I'm going to put a box around that. If you want to just replace that with X or a whole other variable, how do we solve for XB? We're going to multiply both sides by 3/2. 8 divided by 2 is 4. 4 times 3 is 12. So XB equals 12. You can also think of it logically, right? If this is 2/3 of the way, then that means that and that's 8, another third would be another 4. So 1/3 would be 4, another third would be 4, that's 8, another third would be 12. In the diagram above, ZA is 9. So ZA equals 2/3 of ZC. I'm just going to leave it. That's our variable. That's the one we're really looking for there. So ZA is 9. We want to get ZC by itself. If you want to think about that 9 is 2/3, so you would be thinking about what is half of 9, and then we would want to triple that. And the reason I'm saying half of 9 is to get rid of this multiply by 2, you're going to divide by 2. To get rid of this division of 3, you're going to multiply by 3. That's why we multiply it by the reciprocal, because that cancels out that cancels out that. What we do to one side, we have to do to the other side. 9 divided by 2 would split that 9 in half, giving us a third and a third. Times it by 3 would give us all 3/3. 4.5 times 3 is 13.5. So ZC is 13.5. All right, now we're going to move on to the altitude of a triangle. So the altitude of a triangle is the perpendicular segment that travels from a vertex of a triangle to the line containing the base. And it's important that it says the line containing the base, not the side. The line containing the base side. And what we'll see is the line containing, and it doesn't say just the side, because that side, we're going to allow it to artificially extend in certain cases. Because the altitude can be inside or outside a triangle. So for triangle PQS, is PR a median, an altitude, or neither? Is PR, so we see PR right here. So it travels from a vertex. If it was a median, it would come down to the midpoint of this opposite side, and that's not what's happening. It's coming down to the line that contains the base side. So if I was to extend that base, if it was a median, I'm sorry, this would come down even further, triangle PQS. That would be a median, right? It's not what it does. It comes down, it's perpendicular to the extension of the base side. So it's an altitude. For ABC, what is AD? AD goes from the vertex A, it comes down to D, and it splits CB into two congruent segments. So that means AD is a median. All right, Theorem 5.9. Really nothing too special from Theorem 5.9 here. There's usually a property that comes along, whether it's a congruency property. This one says that the lines that contain the altitudes of a triangle are not congruent but concurrent. Which means the three lines do intersect, and they intersect at something called the orthocenter. So they meet, or they're concurrent at, the orthocenter, which seems like an office or in a location somewhere. The ortho, not as cool as the centroid. All right, so we just have a little bit of a diagram or a visual down here. Going back to 5.3, perpendicular bisectors. Okay, they meet at a circumcenter. Remember, the distance from that circumcenter to each vertex is congruent. When we have angle bisectors that are concurrent, they are concurrent at the incenter. That incenter is equidistant from each side. Remember, each measurement would be perpendicular to each side. Okay, so we would come straight down, we would come straight over, we would come straight over, perpendicular. Those would all be congruent. The medians, we have that centroid. Remember, this is 2/3, this is 1/3 of the whole. And then here we have the orthocenter. Okay, when we have the altitudes. Centroid, we use the medians. Okay, make sure you study those, whether it's the vocab, whether it's the properties that come along with that, whether it's the criteria that's needed to create those when it comes to angle bisector or perpendicular bisector, or what a median is versus what an altitude is. Make sure you take a look at this homework. Make sure you practice that. Get ready for the homework quiz. Message me with any questions, virtual office hours. Just make sure that you guys are practicing all of these problems and the vocab for this chapter.